Hey you guys, thanks for coming back again. If you have subscribed, if you are yet to subscribe, please click on the subscribe button and also on the bell beside it to notify you when we drop a new video. Thank you. In the last video, in the previous video, we talked about based on omega function, we talked about what Lambert W function is all about and the cases where Lambert W function could be applied. So we highlighted 8 cases in the previous video, and we proved or we derived a formula for just 3 of them. So here we're going to look at, we're going to derive formulas for 2 more cases. Then we have 3 cases left, and that will be done very soon. So let's see how we can derive a formula for this. I think we've discussed much, nothing to talk about anymore. So now let's go. With the first one, I have x plus e raised to the power x equals p. So the first thing I need to do here is to take my x to the other side. So I have e raised to the power x equals p minus x. So having this, what next? Let me divide both sides by e raised to the power x. So this gives 1 equals, and this is the same thing as e raised to the power minus x into bracket p minus x. So having this, how can I convert it to, just like I've always said, the boy exponential the boy. So from there I can use my Lambert W function. So how can I actually do that here? So what I would do is to multiply both sides by e raised to the power p. I think that's the solution to this. So multiplying both sides by e raised to the power p. Sorry, don't need to write that. Anyway, so I'm going to have e raised to the power p equals, then I have e raised to the power minus x into p minus x multiplied by e raised to the power p. So having this, what next? I'm going to have e raised to the power p equals e raised to the power, this is p, with this, so that gives me e raised to the power p minus x multiplied by p minus x. So with this, I can use the Lambert W function like we have always been doing. So taking the Lambert W function of this and also taking that for this, I will have this multiplied by p minus x. Anyway, let me use a square bracket to differentiate. So what is inside the bracket? So here I'm going to have this e raised to the power p equals, definitely I'm going to have the boy. So meaning the w function of e raised to the power p minus p will give us minus x. So therefore x will be the negative value of the Lambert W function of e raised to the power p plus p. That will be the formula generated for this type of question. So in any cases when you have this, you just make use of this formula instead of you stressing yourself in going through this series of process. So we're going to cite an example just like we used to do. So let's see how it goes. We'll cite an example on that. So if I have, for example, I am given that x plus e raised to the power x equals to 5. So what I would do is, I will just make use of this formula instead of passing through all the series of process. I know that x equals minus the w function of e raised to the power p plus p. So and that gives us x equals the minus w function of e raised to the power 5 plus 5. So inputting this into the Wolfram Alpha, you get your answer straight away for x. So that is just very simple. So now let's look at the second case. And the second case in this video. So let's look at it. So for the second case, this is how we're going to do it. That is going to take a little bit of our time. It's going to take a little bit of our time, just like it's not as simple as the previous one. So that will make it up to 5 cases we have discussed. So the remaining 3 cases will be discussed very soon. in the next video. So now let's see how it goes. I have a raised to the power x plus bx equals p. This is another case of which question can come that might require the use of omega function. So meaning what I will do here is to take this bx to the other side. So I have a raised to the power x equals p minus bx. So what next? Divide all through by a raised to the power x. So this gives me 1 equals p minus bx over a raised to the power x. Can you see this? Very simple, cheap. So now let's move again. I can convert this to 1 equals a raised to the power minus x all multiplied by p minus bx, like I've already said. So we have this. And however, don't forget I talked about the basic facts that x is the same thing as e raised to the power in x. So an x raised to the power minus 1 will be e raised to the power minus in x. Now at the same time, if I have a raised to the power, I'm going to have e raised to the power in a. So meaning if I have a raised to the power minus x, that is going to give me e raised to the power what? Minus x in a. So that's basic facts we need to understand. So meaning we are using this here. So to do that, we have 1 equals, this gives me e raised to the power minus x in a multiplied by p minus bx. So what will I do? Let me divide both sides by b. If I do that, I'm going to have this over b. Anyway, let me just take all through the b here. So if I do that here, I'm going to have b. Let me divide that by b. So I'm going to have 1 over b equals e raised to the power minus x in a. Then this gives me p all over b minus x. So that is what this gives me. So what next? How can we proceed here? How can we turn this function into the boy exponential, so that we can make use of the omega function? So we are looking at it, vividly. What's the next line of action? I think we need to multiply by e raised to the power something. So what would that be? Let's multiply both sides by e raised to the power p all over b in a. I think so. So if we multiply both sides by this, then we would be able to get what we want. So let's move. I would multiply here by e raised to the power pb in a. So meaning I'm going to have exponential p all over b in a all over b equals e raised to the power minus x in a multiplied by p all over b minus x all multiplied by exponential p all over b in a. Permit me. So what next? This and this comes together, and we are going to have e raised to the power p all over b. E raised to the power p all over b in a all over b all equals. This gives me e raised to the power this, and this gives me p all over b minus x into bracket in a multiplied by p all over b minus x. So as you can see, look at what I have now. This is what I have now. So let me continue the next slide here. So by having this, I have to make sure that the power is the same thing as the base. So it's the same thing as what is at the base, so that I can have or make use of my Lambert W function. So how do I do that completely? I still need to multiply both sides by in a. So if I do that, I'm going to have, if I multiply this side by in a, I'm going to have in a into e raised to the power p all over b in a all over b all equals. So if I multiply that, I'm going to have e raised to the power p all over b minus x in a multiplied by p all over b minus x in a. So definitely I already have the boy exponential the board. So I can use Lambert W function. So, however, it's still okay. So let's go. So we have this gives us a W function of in A exponential b all over p all over b in A all over b. And if I take that for this side, it's going to give me p all over b minus x multiplied by in A. So meaning, if I take the exponential of both sides, probably taking this into the other side, I'm going to have, okay, and also I have a W function of in A exponential e raised to power p all over b in A, this all over b. Don't forget, I'm taking the exponential on both sides, so this will be raised to power of e, all equals p all over b minus x multiplied by a. Sorry, still continue. So which means that I have the exponential of what is here, w function of, let me use a square bracket, so I have in A, then I have multiplied by the exponential of p all over b in A, close the bracket, then don't forget all over b, so then use my square bracket, all equals p all over b minus x, then multiplied by a. We have this, so to get the value here, we have to divide both sides by a, so meaning p all over b minus x will be equals to this all over a, so we have e raised to power the w function of in a into e raised to power p all over b in a, p all over b in a, plus, then let's make use of the square bracket like we have been doing, this all over b, then all over a. So that's that. So from there, meaning that this goes to the other side, so meaning I'm going to have x equals the exponential of the Lambert W function of the lane A. Let's make it a little bit up, so in A into exponential p all over b in A, this all over b, then all over a, then that will be what, plus p all over b. So that has neutralized the negative sign here. So like I've said, we can also solve an example on that. So for instance, we said solve a raised to power x plus bx. So let's assume it is 2 raised to power x plus 3x all equals 6. So to solve that is very easy. So we know that x equals this. So we just slot in those values into this, then solve it out. So we can have the solution that x equals the exponential of the Lambert W function of in A. A happens to be our 2. So we have into e raised to power p happens to be our 6. So we have 6 all over 3. That's 3 is p. Then 2. So all over 3. Then that is all over 2. Then plus that is p, which is 6 all over 3. So definitely I'm going to have this, which is going to be e raised to power the w function of that's into e raised to power, that is 2 into all over 3, don't forget all over 2 plus 2. So inputting all this into the Wolfram Alpha will get your answer straight away for x. So this should be the value for x for this particular equation. Thanks for watching. Please subscribe to our YouTube channel. It's free.